So let me wrap up skeletal animation with just a few notes about how to take this further, how you could go beyond what we're going to do in the labs. For example, we're just going to play a single animation in our lab. We're going to call that good. But a real game, that's not going to cut it. You're going to need to blend between animations. You do that when you start and stop an animation. Like I'm in the idle pose, but now I need to start the walk cycle. So I need to blend into the walk cycle, not just snap to it directly. Or maybe I want to blend between the walk cycle and the walking to the right cycle so that I can walk at a diagonal angle. So these are examples of blending multiple animations. Well, we've been talking about doing interpolations and doing blends this whole time. So one more blend wouldn't really be very difficult. You're running animation number 1, you're also running animation number 2, you calculate both poses. And then you simply interpolate between those poses. And you do that before you create the matrix palette. You do that when you're still at the bone transform level. So you calculate the bone transform for, for like animation 1, you're between 2 frames. We already did a blend there. So you get between 2 frames of animation. And then maybe you're on 2 different frames of animation for this other animation. So you do that too. So for animation 1, you have 2 keyframes you're blending between. So that's 2 bone transforms. You do that blend. And then you have 2 bone transforms over here. You do that blend. And now you have 2 bone transforms to blend between those. And so, yeah, that's how you would layer up some more animations onto this thing. You can take it further, though. You can make an entire blend tree, what we would say, blend tree of animations, where you were playing the idle and then you started walking. So we're blending from idle to walk. And while we're doing that, we're also going to start moving diagonally. So now we're moving a little bit of idle, some walk forward, some walk to the right. And then you hit the jump button. And so now you're doing a little bit of idle, a little bit of walk to the forward, a little bit of walk to the right, and now we're starting the jump animation on top of all of that. So it becomes this whole tree of nodes that are all blended together, and ultimately we just make a bunch of bone transforms, and we take those bone transforms and turn them into a matrix palette. Okay, animation compression is something we mentioned earlier. I didn't really talk about how to do it. I touched on the idea that not every bone needs every keyframe. So that's one way you can do get some compression, is to drop the unnecessary keyframes. One thing you might even consider doing is to do that automatically. One way you could do it is to let the artist do it, and when they set the keyframes, those are the keyframes we'll use. But a lot of times the keyframes that they add might be unnecessary, because maybe the keyframe might just land directly on the interpolation between the adjacent keyframes. So you could write a little tool that spins through the animation and checks to see if just interpolating across any particular keyframe would cause an error. If it causes an error within a certain tolerance, then maybe we don't need that keyframe. So you could do that, and you could do it automatically. Another thing is you could just compress the data itself. What do I mean by that? Well, there's 2 ways of looking at that. One is, does every keyframe need both the rotation and the position? Or are there some bones, maybe some bones only rotate. In fact, I think most bones only rotate. So there's no need to store position keys for those bones. You could split those apart. And then you could go further and you could compress the way you store the quaternion. Do you need 4 floating point values? So 4 times 4, 16 bytes. Do you need 16 bytes to store every rotation key? Or could you reduce the resolution of that a little bit? Okay, another idea. We are using linear interpolation for all of our keyframe interpolation. But the animation packages probably use a cubic interpolation. And I'm not really getting into what that is. It just means you use a cubic equation instead of a linear equation. So if you also used a cubic interpolation, then your interpolations will better match the package that the animator used when they were creating it. And if you could match it well enough, then you could ultimately result in a higher fidelity result with a lot fewer keyframes. All right, how to really take it further. Here's just a handful of ideas to think about. If you're interested in animation, here's some stuff to do research on. This is beyond the scope of this class, but these are absolutely all parts of engines that are out there. So first, key phrase you'll hear a lot, you'll hear about IK, or inverse kinematics. Inverse kinematics, that's what IK stands for. What that is, as the name sort of implies, it's the inverse of what we've been doing so far. What we've been doing is you say, here's the pose, and based on this pose, we'll calculate where all the bones land. Inverting that is to do it the other way, is to say, I don't know what the pose is, but I know where I want the hand to be. For example, I want the character to reach out and grab the cup off of the desk, right? So I want the character to reach out, grab this coffee cup. And I don't know exactly where that coffee cup's going to be in advance. So what I'll do is calculate what pose does that arm need to be moved into so that the hand grabs the coffee cup. And that's a pretty cool little calculation to do. And we call that IK, inverse kinematics. Another idea, and this one's actually mathematically very simple, called additive animation. Additive animation, and I'm right here now, additive animation just means instead of doing a linear interpolation between two poses, we could store the additive animation as a difference between the base animation and the varied animation. Now, that's particularly interesting for a couple of reasons. One is it could just be a good way to do data compression. If you've got just an animation that's just a variation of another animation, then maybe most of the bones don't need new keyframes. They can just use the exact same keyframes from the base animation. And if we store it as a difference, instead of a whole animation to blend to, we store it as a difference, then only the bones that vary from the base even need those keyframes. So that's useful. Another way we can use that same technique is to say, well, what if we then added that difference to some other animation that was kind of similar to the first one? And so then you can do things like, say, a breathe cycle. The classic is a breathing cycle. Your character is breathing in and out, in and out, in and out. And that's just a simple little looping animation. We could add that as an additive animation on top of the idle animation. So now we have a character that's idling and breathing. Why is that useful? Well, then we could have an alternative version where the character is breathing fast. Maybe the character is out of breath a little bit, so they're breathing faster. So now instead of adding the base breath animation, we add the fast breath animation. And not only is that pretty efficient data-wise, but we can add the breathing animation to the walk cycle too, and probably get away with it. That will probably still work because the walk cycle and the base idle are similar enough that if we add the differences that represent breathing, we can now add breathing onto these other animations. Okay, next up, partial body animation. One of the things that happens in a modern game is the number of options of animation tends to explode. What am I talking about? So I've got my character in an idle pose. I got my character walking. I got my character running. Very simplistic 3 set, say idle, walk, run. Now the character picks up a pistol. So now we have idle with a pistol, walk with a pistol, run with a pistol. Now the character picks up a rifle. And you carry a rifle with 2 hands, not with 1 hand. So we have a whole new set of animations. We have idle with a rifle, walk with a rifle, run with a rifle, etc., etc., etc. Now give the character a baseball bat. Now give the character a golf club. I don't know, whatever, right? All these different things that are, for some reason, they're held differently, and that causes the animation to explode, the number of animations. Well, one thing we might be able to get away with, at least with some of these cases, is to split the character, like for example, upper body and lower body. Somewhere in the middle of my spine, I'll split and say from the hips down, we'll just have idle, walk, and run. And then for the upper part, maybe we can just play the holding a particular thing animation. And now that's not really going to get us very far, because running with a rifle is not the same as running with nothing with your legs and then your upper body is just holding a rifle. That's not going to work, right? But we can get away with it for some things where they are similar enough that we can just use a technique like that. Okay, and that gets us on to the more advanced stuff like ragdoll. Ragdoll is sort of a whole category of physics-driven animation poses, where instead of having the artist necessarily pre-create these animations and we play them, we'll let the physics engine adjust the character's pose in real time. So what we'll do is we'll assign masses and spring stiffnesses to each of the bones that the character is made out of, and then apply an impulse, apply some force to the character, and let physics decide how those bones should move. We call it ragdoll because especially the early implementations, but even still today, it tends to create a look that does not have intention. It does not seem like an intelligent thing is trying to do this. It just seems like what happens if you switched off the brain and just turned it into a ragdoll. It's literally a ragdoll and you just dropped the character. That's what it tends to look like. To bring it all together, though, something like Assassin's Creed or the Naughty Dog games and stuff will use some really advanced combinations of these things to get truly high definition traversal animations. Now, what are they going to include? It's going to get really crazy, where putting your feet on the ground when the terrain is not flat is going to require a little bit of IK. You have to adjust where the foot is in the animation so that the legs don't stick through the ground, or that the legs don't float above the ground. So we can do that with some IK, but to maintain that intention to where it looks like a human being is planning and thinking about where they are putting their feet, there's a whole lot more to it. You would have to predict where the character is moving, and so in advance have the feet turn and have the feet reach out to where they need to go. And is that going to be like a hole in the ground, or does the character need to take a slightly wider step here to step over a gap, or a slightly shorter step here so that they can prepare to take a step over a gap that's coming up? That kind of thing. And there's just a great deal of work that goes into that kind of stuff. A lot of fun if you're interested.